what it will take place is like it is computing the total data here with coefficient, okay, to make it much more load balanced. Like first one, if you say that phi 1 plus this one d1, okay, so it's this one taking a coefficient with it and then sending data to the next node. So it will be the total data that will take place. How it will take place, just give me a second, I'm going to explain in the next slide. Here in slide number 13, if you see, okay, in compressive data gathering, the sync will be sent by a few weighted sums. Actually what it is, just hold for a second. Yeah, here what we were saying that it will like this one, it will send data to this to this in baseline, but in compressive data gathering, one will multiply its data to some coefficient phi 1, okay, and send it to this one second node. Second node, what it will do, like its data, whatever data it has, it will multiply it to coefficient phi 2 and add these two data and send it to this third node. Okay, so what it does here, it is doing one addition and one multiplication, but sending one data only, the sum of that data. Okay, so here also it's the same thing taking place. So it will be like even load distribution is going to take place with one multiplication and one addition only.
Issue. Just tell us the important slide numbers, dude.
Yeah.
Because like we don't have time.
Yeah,
only
in 14, this is the same thing that has been explained.
Just mention the slide number.
Yeah. In 15th, if we see, yeah, in 15th, just see the measurement matrix in that tree. What S5 is going to do? S5, S4 and S3, sorry, S4, S5 and S6 are multiplying its data to the coefficient and sending into S3. Okay, after receiving data from S4, S5 and S6, S3 will, this one, multiply its data to phi S3, phi D3 and sending all the sum to S1. Similarly, this will take place and the sync will receive the total data. 16, yeah, 16 is the based over that only. Here in 17, here we have shown in compressive sensing that it's going to take place with the this one sampling matrix, that is the coefficient that we are taking. We are multiplying the data and sending it to the node.
Ratio. Mention the slide numbers.
Yeah, that's what I'm mentioning.
Just slide numbers.
Yeah. Here. Yeah, reconstruction optimization, slide number 18. Okay, for sparse signal whose random projection. Yeah, actually what it says that if there are sparse signals, there are going to be a lot noise that's going to take place. Okay, so to reduce that, we can use the linear programming technique. Okay, and minimize problem through this. Yeah, 20th is of no use. There's nothing given in that.
Yes, like that.
Recover data with abnormal readings. There's nothing much now in the slides, and we can directly move to. Yeah, here 21, 22. Yeah, in 23, what we says that as it was. Yeah, in the graphs that was shown earlier that we didn't cover up, there's nothing much given. They were saying that if there are projection over this slide, like it's having some abnormal data, okay, so they won't come under the this one DCT solution. So for that, this is that we can propose this formula D equal to D0 plus D1. We can add these to abnormal activities and can get the data. Okay. Here NS2 simulation, there is nothing much to be covered in NS2. Here chain topology and grid topology that we need to cover only.
Rishu, in your paper, in your presentation, yeah, can you just tell us the slide index which are important one, like slide number 1 is important, slide number 6
that's I'm going to cover up. Just let me finish this one. And
that's true, because we are running out of time. So please try to cover the important topics.
Yeah, chain topology and grid topology I'm talking
don't go for all
now.
Seriously. because otherwise we'll left
Because
with
in
only
2 hours it won't
yeah.
be possible to finish.
Explanation.
We may not be
we are
covering
covering
all the
the-
presentations.
Just
Just
important.
focus on
Just focus,
important topics
just
of your
don't
paper.
take-
That's it.
Yeah.
Just tell us the slide index.
Yeah. This is all I think that needs to be covered here in my slides, and in it the important technique is compressive data gathering, CDG. And just for a second, let me tell you the slide numbers.
Your paper number is 22. perhaps.
Yeah, paper number is 22.
You
Yeah.
okay? 23. You mentioned
It's
22.
22.
23. It's 23. It's 23.
I'm so sorry.
Yeah. Okay.
Okay. Here it is the slide number. Yeah, that important slide number is slide number 11,
Yeah.
13, and 15. Okay, and then the last thing is this data gathering at slide number 18. These are the important ones that we need to cover. Here, after that, chain topology and grid topology, we need to read a bit of that.
Slide
Okay.
number. Slide number.
The slide number is 25 and 26.
Okay.
Okay. In chain topology,